Okay, so that basically summarizes everything I think that we know about magnets. Okay, later on, after class, just gonna have maybe draw a mini mind map together, just the two of us anyway. We'll just come out with a mini mind map on how to summarize the entire topic. Okay, Claire? All right. Now, I think that you might be doing magnets later on when you're in maybe now or maybe later on, because usually magnet is the last topic for primary 3. Yeah, but I think if let's say you have done it, have you done magnets in school? Has your teacher started on that?
Yes.
Okay, great. Okay, so then I think that's that. Okay, so let's just go through the question now. Okay, Priscilla placed 3 rings through a wooden pencil as shown below. She observed that Z and Y were in contact with each other while X was floating above Y. Which of the rings were definitely magnets?
Y and X.
Very good. Why is it Y and X?
Because Y is like X is just floating above Y.
So what does it tell us about X and Y? So they're repelling, right? So in this case, if they're repelling, it tells us that, because one thing for sure we know is that when two things repel each other, it's 100% that both of them are magnets, because only magnets repel magnets. Am I right? Okay. So in this case, of course, X and Y are definitely magnets. The answer is A. Good. Okay. Well done. Okay. Now let's move on to the next question. Owen conducted an experiment using 4 magnets of different magnetic strengths. He hung the magnets from a support at different heights using strings as shown below, and placed some thumbtacks below the magnets. So which one of the magnets had the weakest magnetic strength?
M.
M. Is it the weakest or the strongest for M?
Because
Okay, now if you notice, right, M is able to attract. In fact, all of them are able to attract 2 thumbtacks. Am I right? All of them attracted 2. But if you notice, M is the one that is able to attract 2 thumbtacks from the furthest distance as compared to P. Okay? So which one is the weakest? The question is asking for weakest.
P.
P, yes, they're very good. P for penguin, right? Yeah, so P is the weakest because even it can only attract 2 at a low height, whereas M is so far from the thumbtacks, yet is also able to attract 2. Okay, so in this case, yes, the answer is C. Very good. Okay, now I'm going to move on to question 3. Study the classification chart below. Objects, magnetic and non-magnetic. Now the question is, which of these have been wrongly classified? So wrongly. Okay, so this one is wrongly classified. So in this case, which of these are wrongly classified? Let's look at magnetic. Is steel wire correct? Yes or no? Is steel wire magnetic? Is it magnetic? Steel wire? Which one? Yes. Okay. Is key magnetic? Depends, but I think we would think it's magnetic, iron, and of course thumbtack as well, like the previous question. Brass is actually an alloy. It's a type of it's a mixture of metal. So we learned that, I think if you can recall, what are the magnetic materials? School is not cool, right? So we have steel, iron, nickel, and cobalt. So 4 of them are magnetic materials. Okay, so which one is wrongly classified? It will be the brass button. This one is wrong. Thumbtack is correct. Okay, so non-magnetic, okay, silver, gold, copper, these 3 metals are non-magnetic. They are non-magnetic, so they are correct actually. They are classified correctly, right? So in this case, which one has been wrongly classified? It will then be your still safety pin, because safety pin is considered magnetic. Usually safety pin is made of iron, right? So this one should have been magnetic, whereas your brass button should have been non-magnetic. So the answer is B, because the question is asking which one is wrongly classified. All these are correctly classified. Okay, Claire? Yes? Okay. If you don't know, please ask. Yeah, it's just the 2 of us today. I think there should be 1 more student, but I think given the time now, I don't think she's coming in already. Yeah, so it's just us. So don't be shy to ask. Oh, wait. Okay, hold on. She's actually in the waiting room. Let me see. And she is Wen Xing. Is she Wen Xing? Hi, Wen Xing. Is that you? Yes. Okay. Thank you so much for turning on your video. So Wen Xing is here as well. Very good. Okay. Well, Wen Xing is new, so basically a few things to take note of. I think you've been doing a great job so far. Turn on your video, mute yourself. If you have questions, click on the chat icon and you can just type in the chat. Or you can also actually you can also just there's this icon, right, whereby you can raise your hand. So when you click on that, it will prioritize you in front, and then I can get you to answer the questions. It's just a few house rules that we have. Okay, and of course, if you really need to go to the toilet, I will not stop you, because I understand you need to answer nature's call, right? So just go ahead and maybe just drop me a message somewhere. And of course, please come back after your toilet break. Okay, Ken? Now, one thing, we are actually covering magnets. Since you are here the first time, we are actually at lesson 4 of magnets already. Okay, so what we do here is that we do have our own curriculum. So with Claire has been with me for I think 2-3 months already. So we actually follow a particular curriculum, but not to worry, we will definitely cover all the topics required for you to do your end of year exam. Okay, Ken? So maybe just a quick check. Have you learned magnets in school? No, not yet. Oh, okay. Right. If that's the case, then I think, okay, maybe as we go along, if you have questions, just ask. Okay, just take it as like learning it in advance of school. I think there's nothing wrong with that. In fact, it's always good to learn a bit in advance. Yeah. Okay. Now let's move on to the next question. In setup A, magnet M was placed under material A, used to move cube X, which was on material A. Okay, so that means this one is setup material A, setup A. If you notice, when we put the magnet here, it was able to move the material A to the left as well. Yeah. And then for setup B, you realize it was not able to move, even though I moved material M. Okay, so which of the following explains why metal cube X did not move? Right. So metal cube, magnet M. Okay, so I think this one is labeled wrongly. Okay, this is magnet M. This is also magnet M. Right? So it was used to move it. And in setup B, when material B was used, metal cube X did not move. So which of the following explains why metal cube X did not move? So over here, if you notice, metal cube X is stationary here. So can we say that metal cube X is a magnet if it doesn't move? Yes or no? Is this a magnet? Is this possibly a magnet? Because this is a magnet. So I think for Wenxing, you have not learned magnet. Basically, for magnet, right, when magnets and magnets meet each other, they either attract or repel, depending on the poles that they are facing each other. Okay, so in this case, we cannot say that metal cube X is a magnet, right? Because if metal cube X is a magnet, then it should have some form of interaction. One of them might repel, one of them might attract. Okay, so in this case, okay, let's take a look at B. Option B says that material B is magnetic. So again, if this is magnetic and this is a magnet, it should have attracted it. But because it didn't move. So if it didn't move means we cannot say that B is magnetic. Okay, magnet M has no poles. Okay, so obviously, okay, so when this one, material B is used, magnet M has no poles. This is also wrong. By right, magnet should have poles. So what can we say about metal cube X? Metal cube X is not a magnet. That's what we can say. Okay, do you understand? Yeah? Okay, this one is a little bit more complicated. Basically, they use the terms, okay, I think this one, it should have been magnet M. Right? So there were some terms that I think there's a typo error. This one is magnet M. Okay. Then of course, magnet M was placed under, this one should have been magnet M also. Then the one on top is actually metal cube X. Yeah. Okay. Now let's move on. Mei Ling wanted to investigate, let's see, to investigate whether the size, okay, so this is the aim of the experiment, to investigate whether the size of a magnet affects the greatest distance from which it can attract a paperclip. So this is what we call the aim of the experiment. To investigate the size of the magnet is what we call the change variable. We are changing this variable. And then the greatest distance from which it can attract a paperclip, that will be your measured variable. Okay, so which of the following variables should she keep constant? Of course, the size of the magnet is the change variable, so we are not keeping it constant. Keeping constant means it is going to be unchanged. No, we are going to keep everything in all setups the same, right? All these variables are the same, so it's an unchanged variable. So which of the following variables should she keep constant? Type of magnet, right? Should we keep type of magnet the same? The only thing we should change is the size of the magnet, right? So the type of the magnet we should be keeping the same, isn't it? Okay, the size of the paper clip, this paper clip should also be the same. The type of paper clip